Question 8. Determine f prime x from first principles if f of x equals x cubed. Now, first we must see that we are dealing with first principles. So we want to find a derivative of this function f, but we need to use first principles. So a good way to begin is just to check what would the derivative be. Well, I hope we can all see that the derivative we must end up with will be 3x to the 2, because we times 3 with our base and a minus 1 from our power. Alright, so the first principle's formula looks like this. F dash of x will equal the limit as h approaches 0. So never actually gets to 0, approaches 0, of f of x plus h minus f of x all over h. So this is our formula. We have a limit and we have some expressions for f of x, where the one has a plus h in it and the other one is just f of x. Alright, so step number 1. Let's determine f of x plus h. Well, all we need to do is, if f of x is equal to x cubed, and our alteration to f of x is where x has a plus h, all we need to do is sub in x plus h into our x. So f of x plus h will be equal to x plus h cubed. That's all we're doing. So then let's times that out, shall we? That'll be x plus h, x plus h, x plus h. Alright, now we're just going to do some algebra. So that'll be x squared plus 2xh plus h squared. And we mustn't forget the last bracket. X cubed plus x squared h plus 2x squared h squared h plus 2x squared h plus 2xh squared plus xh squared plus h cubed. So let's check that. X cubed, x squared h, 2x squared h, 2h squared x, xh squared plus h cubed. Alright, perfect. There's a bit of algebra in this question, these types of questions, but it's alright. Just keep your thinking hats on and work slowly. So we can now rewrite this. And we must rewrite it properly each time, putting the limit in the correct space, else it will be incorrect. So f of x plus h we've determined to be, can we simplify this? Let's just have a look. Can we simplify this? X cubed, so that'll be x cubed, x squared h, plus 3x squared h, take this and this away, 2x h squared plus xh squared, plus 3xh squared plus h squared. There we go, that looks like it's been simplified. So we continue. X cubed plus 3x squared h plus 3x h squared. So these, we were just grouping terms here, that's all we were doing. 3x h squared plus h cubed minus our f of x, which was x cubed, minus x cubed all over h. Right. We can see now that x cubed will cancel. So we rewrite. What do we have? The limit as h approaches 0 for 3x squared h plus 3x h squared plus h cubed. 3x squared h plus 3x h squared plus h cubed all over h. Now we can simplify even more. Remember, this term over here is exactly equal to 3x squared h over h plus 3x h squared over h plus h cubed over h. Now what can we do? We can see we can cancel. So now let's rewrite this once more. F dash of x, the limit as h approaches 0, so it'll be 3x squared plus 3x h plus h squared. Now, what now? Well, we still have our limit, and we know how to take limits. In an example like this, where it's a polynomial, we can, well, this is not a polynomial, but in the case of derivatives, when using first principles, all we need to do here will be to sub in our h, which approaches 0. So I just want you guys to understand is when we're dealing with limits, is h isn't actually equal to 0. It's almost like if we have a function like this, and here's h. It never actually reaches h, for example, but it gets so close that we can treat it as if it's 0. So if we sub in h into our expression, what do we get? We end up just having f dash of x is equal to 3x squared. That's exactly what we found in the beginning. So we have found the derivative of f of x using first principles. And that is the question solved.